Hi, and welcome back to the Jelvix channel. Today we're diving into the world of Rust and Golang, but with a twist. Guided by feedback from our Jelvix experts, we'll explain the key differences using memes. Because, let's face it, nothing sums up programming struggles and strengths. But before the battle starts, our Jelvix developer team wants to emphasize both Golang and Rust are modern and robust solutions. So it's all about context. Each language is optimized for different things, so your choice should be determined by what suits your needs and the problems you want to solve with it. With that in mind, let's start with the first Golang differentiator, its concurrency model. Go is designed with concurrency as a core feature. Go excels at building highly concurrent applications with minimal developer effort. And for that, Go provides lightweight threads called Go routines, as well as channels to communicate efficiently between them. This approach makes it easy to write programs that can handle multiple tasks at once without the usual heavy overhead, which is great for cloud services, web servers, and distributed systems. However, not everything is sunshine all the time. With great concurrency comes great responsibility and race conditions. Sometimes, when running tests with Go routines, you might run into a data race, two threads trying to access shared data simultaneously. It's not a fun surprise, and debugging these can definitely give you a headache. Well, but what about concurrency in Rust? Go simplifies it with Go routines and a built-in runtime, while Rust also supports concurrency with native threads and async runtimes, like async std and Tokyo. However, Rust doesn't have lightweight Go routines like Go. Instead, it requires careful management of concurrency through its ownership model and type system, offering more control but demanding more effort. Although Go's concurrency is easier, Rust's model, while complex, ensures safety and performance, making it a top choice for many developers despite the learning curve. Speaking of Rust differentiators, its memory safety is a game changer. Rust emphasizes memory safety without requiring a garbage collector. Its unique ownership and borrowing system ensures that data races, null pointer dereferencing, and memory leaks are almost impossible. Yet, while Rust's complex string system provides memory safety and type safety, it can feel overwhelming for someone transitioning from simpler string representations in other languages. In contrast to Rust memory safety, Golang uses garbage collection, which automates memory management by periodically reclaiming unused memory, simplifying development but potentially introducing latency during the garbage collection process. Thus, while Rust emphasizes performance and safety, Go is more geared toward developer productivity and ease of use through automation. To add to Golang's ease of use aspect, Go is known for its minimalist, easy-to-use features. Go avoids language features that might add complexity, such as multiple looping constructs. In fact, one single loop type is all you need. Sounds nice, doesn't it? Because of such straightforward syntax, Go is ideal for projects where rapid development and collaboration are key. As for Rust, it, similarly to Go, primarily uses the for loop for iteration, but includes additional constructs such as while and loop for greater control in specific scenarios. This provides Rust with more expressive power for complex tasks. Another vivid example of Rust's complexity over Golang's minimalism is cross-compilation. Go excels in cross-compilation with minimal configuration needed, while cross-compilation in Rust can be more complex. Rust requires a detailed configuration of target specifications and toolchains, which may be less intuitive for some developers. Meanwhile, this level of control can be particularly beneficial for developers working on projects that require deployment across multiple platforms, such as embedded systems, operating system development, or applications targeting different environments. Moving on to another benefit of Rust, it's known for having a powerful compiler, and here's where Rust definitely softens its learning curve. Rust compiler helps programmers deal with mistakes in their code by providing clear, actionable suggestions. Such detailed and informative error messages enable developers to understand and resolve issues quickly. Furthermore, the Rust toolchain includes Cargo, the package manager and the build system, which simplifies dependency management and project setup, enhancing the overall developer experience. Meanwhile, the Golang compiler is known for its speed and efficiency. The Go compiler features a fast compilation process that enables rapid development cycles, making it ideal for building large-scale applications. Additionally, the Go toolchain includes Go, a command line interface that streamlines various tasks, such as building, testing, and managing dependencies. But what about Rust's performance? Well, Rust's zero-cost abstractions and fine-grained control over memory allow developers to write both safe and high-performance applications, especially comparable to those in C and C++. Summing up, solutions like Python and Golang are fun and easy. Rust, on the other hand, may feel for beginners like going through a battle. Its complex syntax, including Rust's borrowing, ownership, and lifetimes, make it harder to grasp. Yet, at the cost of a steeper learning curve, it allows for more control. This can be extremely beneficial for systems programmers, embedded systems developers, and those working on performance-critical or concurrency-intensive applications. But in fact, Rust is used for way more cases than that, being a favorite option for over 3.5 million developers. Just to compare, meanwhile, the Golang community totals approximately 2.5 million users. We hope you enjoyed this video. On a final note, check out the head-to-head comparison of these two frameworks. So, which side are you on? Golang or Rust? Drop your perspective in the comments. Also, don't forget to support us by liking this video, subscribing, and pressing the bell button. And there's always even more insights we've got in store, such as the ones in this video. Bye for now.